Howdy.
Hi.
Huh?
It's a little chilly out.
It's a little chilly. Not that bad though. All right. So we're gonna do the determinant of a square matrix. We're gonna start off with that problem I messed up last time, and this time we're not gonna mess it up, okay? So I'm gonna give you 3 minutes to not mess it up. Okay, so the key to this problem is to set it up properly. I think that's what we learned last time. So if I want to find out the cost of the equipment for each team, I need to take the price times the amount I need. Okay? So I'm going to set up two matrices. The first matrix is going to be my price matrix. And I want to follow the order they have here. So I'm going to do bats first, then baseball. Why am I putting a comma? Then baseballs, then gloves. Okay, and then I'm going to put the amount they need over here. So I'm going to multiply this by this matrix, basically, just copy it over. 12, 45, 15, 15, 38, 17. And that'll tell me the total amount of money I need. If I check now do my matrix multiplication, this matrix is a 1 row by 3 columns. It says 3 rows and 2 columns. So these match. That's how you know you're on the right track. My answer is going to be a 1 by 2. So 2, 2. To get the element right here in the first row, first column, I'm going to multiply 90 times 12, which you should notice is doing what we wanted to do, right? It's taking the price of the bats times the number of bats I need, right? And then it does the same for baseballs, and then it does the same for gloves. So if I do that, 90 times 12 plus 6 times 45 plus 60 times 15. I get 2,250. Again, that's 90 times 12 plus 6 times 45 plus, oh my gosh, times that. All right, so that's how much it costs to equip the women's team. For the men's team, right here, I'm going to do first row, second column. So 90 times 15 plus 6 times 38 plus 60 times 17 is 2,598. 2,598. Yay. Not too bad. So again, for this one, I understand that if this word problem was probably giving you on the ACT, you would probably not use matrices to find it. You would just do it by hand really quickly because it's not too bad. The real point of this example is to show you how this methodology works, because when businesses have a whole bunch of equipment they need, right? They have like a huge list of 25 different things they need for each building or each franchise, right? And then they get the price it costs. They use matrices to do it once these things become really large and complex. All right, so a small example to show you how it could be translated into a really big example that you could then apply in real life. All right, what we're doing today, finding determinants of a 2x2 matrix. I don't know why it cut off the 2x2, but it did. We're going to find determinants of 2x2 matrices. That's easy peasy lemon squeezy. You're going to be like, Mr. Lake, that's great. I love it. We're going to do this step, but really the only reason we find minors and cofactors of square matrices is to find the determinants of square matrices. So if you leave today being able to do C, you know how to do B. So once we know how to do 2x2s, we're then going to expand it to figure out how do you do a 3x3 or a 4x4 or a 5x5. This is the hardest thing we'll do since the break. But it's only difficult in the way matrix multiplication was difficult. It's a weird process that's not necessarily intuitive, but it isn't actually hard to do the process. It's just weird. And so remembering the steps that you're supposed to do and how to do it takes a little practice for you to get in the swing of things and understand what's going on. But once you do, you're like, this isn't hard. It's just multiplying and dividing, or multiplying and adding. That's all it is. All right. Let's do the easy peasy lemon squeezy step first. The determinant of a matrix that is 2 by 2 can be written in any of these notation. The most common is det of A, but you'll also see it very commonly written as just like the absolute value of A. And they could just put the absolute value in the matrix instead of the brackets. All three of these things are asking you to find the determinant of these four numbers. How do you find the determinant of those four numbers? Well, it's really easy. You just cross multiply and subtract. So I'm going to do the main diagonal from top left to bottom right minus the other diagonal. That determinant will give you a single number as your answer. And then that answer can be used to help you do a whole bunch of things. It can help you solve system of equations using Kramer's rule. We'll learn about how to do that on Wednesday. It can be used to find inverses of matrices, which we'll do on Thursday. So it has a lot of applications. We're not really going to get into those today. We're just going to get into the mechanics. It can also be used to find like the area of geometric shapes when you write the coordinates of the shape in a matrix. I needed more coffee this morning. Maybe I'll run to Dylan's during lunch and get a Dr. Pepper. That could be good. I think that's a good idea. I have mac and cheese left over with peas. I don't know if I'm in the mood for that right now. But again, Dylan's doesn't have a lot of very good vegetarian options if you just pick up. We'll see. The problems Mr. Lake has, insurmountable. Okay, I think we're ready to move on. So let's do it. To find the determinant of this matrix, I'm going to do 2 times 2 minus 1 times negative 3. Which I believe is 4 plus 3. So that's 7. Yay? See? Not too bad. If we do B, the determinant of B is 2 times 2 minus 1 times 4. Again, you always, the top left to bottom right, that main diagonal is always goes first. And then the other diagonal is the one you subtract. Though for this one, it doesn't really matter because that's 4 minus 4. So that's 0. Whoop. Can you think of anything better you could be doing besides finding the determinant of 2 by 2 matrix? I can't. Can't think of a single thing. All right, your turn. All right, first I'm going to put 3 on the board. The first person to get the determinant of all 3 gets to feel really good about themselves. The other 2 has to feel like, oh, it's Monday, whatever. All right, here you go. Here's the 3. 3 minutes on the clock. If you get it under 3 minutes, you can feel content. Hmm. Okay. Shall we just have everyone take one? That seems fair. Caitlin, you want to start us off?
Yeah, so we take 1 times -1, which is -1, and then 3 times 2, which is 6, so 1 minus 6 is -7.
Yay! Good job. Ty, what you got?
All right. So 4 times 0
Okay.
is 0. And 3/2 times 2 is 3. And then -3.
Yay. We got the last one?
5 times 2 is 10. -4 times 0 is 0. So 10 minus 0 is 10.
Yay. Okay. So now we did the easy peasy lemon squeezy stuff. So now we're going to do the stuff where I'm going to explain it one time. You'll be like, that makes no sense. I'm going to give you steps. You're going to be like, that makes no sense. Then we're going to do one together. And you'll be like, that makes some sense. And then you're going to do it on your own. And you'll be like, oh, this isn't as bad as it looked. Don't write any of this. Okay? So these are the formal definitions. And kind of like the formal definition of matrix multiplication, it's not very useful. But this is how it works. If I want to find the determinant of any square matrix, I have to find the minor of an entry in that matrix. To find that, I delete the row and column of that entry from matrix A, and that'll leave over a smaller matrix, which I then take its determinant of. That's the minor. I then multiply the minor by either positive or -1, and that gives me the cofactor, depending on where it is in the matrix. Once I have my cofactor, I then multiply it by, again, that original element, and that gives me one term. I repeat that for every other element in that row or column. I can pick any row or any column to do this math with, and that will give me the determinant. Okay, so back to this part where I said it multiplied by -1 or 1, depending on what position it's in. That is determined by -1 to the power of I plus j, what row or column it's in. But the easier way to get that is it follows a really nice pattern. It follows this checkerboard pattern. So now this you should write down. For the side change, you should write down, this one. And maybe that one. To be honest, you're never going to, the only time I would ask you to do a 4x4 matrix by hand would be for extra credit. So if you want to draw the second one, it's for extra credit. But also, to be more honest, like you could probably make it up without needing to draw it. Because all it is it's a checkerboard pattern where you start with plus in the top left. Right? So it goes plus, and then the two ones adjacent to it are minus. Then this opposite diagonal is all pluses, then all minuses, then plus. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So then to get the fourth one, right, you would just do the opposite side. Minus, plus, minus, minus, plus, minus, plus. Okay. And for any bigger matrices, you would just continue to expand on that checkerboard pattern. Okay. So that's the formal definition. So here's what you actually do. So the only ones we'll really do by hand are 3x3s. So these are the steps to do a 3x3. First, you need to find the cofactors of, okay, right here, to be honest, this could be any row or column. So you're going to pick any row or any column of your 3x3 matrix, the one that looks the easiest, and you're going to find the cofactor of those three elements. How do you find the cofactor? To find the cofactor, you find the 2x2 determinants that are created by eliminating that element's row and column. And then you will multiply that number by the sign change from that chart we just copied down. If you have accomplished step A, the rest of this is easy. You then multiply each cofactor by the element that created it, and then you sum your three products. So basically, to find the determinant of a 3x3, you have to find three 2x2 determinants. Multiply by the sign change, multiply again by the element that made it, and then add your three answers together. I'll walk you through the steps by hand on what a 4x4 would look like, and hopefully that will convince you to never do a 4x4 by hand. I imagine that this is what, like back in the 60s, 50s, 70s, when NASA hired calculators, right? I imagine those people did a lot of these. That and square roots, and then all the trig stuff, looking up all the reference charts. I think it'd be kind of fun to be a calculator. It would have been a fun job. All right, we ready to see it in action? All right, let's see it in action. All right, so find the determinant of A. So first thing we're going to do is we're going to pick the row or column that looks like it has the easiest numbers. For us, I think that's just the first row. This last row looks pretty good, but I think the first row is the easiest. All right, so I'm going to find the cofactors of that row. For the first one, if I eliminate its row and column from the matrix, I'm left with this 2x2. So I'm going to find the determinant of -1, 2, 0, 1, which is -1 times 1 minus 2 times 0, which is -1. I'm then going to multiply that by the sign change. So you need to go look back. the sign in the top left is +1, so I'm going to is positive, so I'm going to multiply that by +1. So it'll just stay -1. This is my first cofactor. All right, I'm going to do that again, but this time I'm going to do it for the 2. So again, I'm going to eliminate this row and now this column from the matrix. And what I'll have left is a 2 by 2 matrix with 3, 2, 4, and 1. Everyone see where those 4 numbers came from? 3, 2, 4, 1. Determinant 3 times 1 minus 4 times 2, which is what? 3 minus 8. So that's -5. Now we multiply it by the sign change. Okay, so if I look this time, this spot has a negative here. So I need to multiply this by -1. And that'll make it +5. One more time. To finish out this row, the last number in this row is 1. If I cross out the row and the column, it leaves me with this matrix. 3, -1, 4, 0. So it's 3 times 0 minus 4 times -1, which is +4. Check the sign change. It's positive. So I'm going to multiply this by +1. So it'll stay 4. Right, I split B and C into separate ones, but really you could do those two at the same time. So I'm going to multiply each of these numbers by the elements that created them. So I'm going to multiply this by 0. I'm going to multiply this by 2. And I'm going to multiply 4 by 1. That's not a 1. And then add those answers together. So that's 0, 10, and 4. Answer is 14. Okay, when you're doing this, realistically, I would not have done any of this first line. Because I know when I use this one, whatever the determinant is, get out of that, I can multiply by 0. Right? So I could have skipped this whole line and just did the 2 and the 1. Whenever you have a 0, it lets you skip the entire determinant. So that's why I say and stress that you can pick any row or column to find the determinant of this matrix. Because if you see one that has a bunch of zeros, it's going to make your work so much easier. All right, let me show you how to do this in the calculator, because after you've done these, you might not be confident you got the right answer. And if you want to do anything bigger than a 3 by 3, you have to use the calculator anyway, unless you want to go insane. All right, so to do that, I'm going to hit second matrix. I already plugged it in from earlier, but yours is probably blank here or not the correct matrix, right? So I'm going to go to edit, type in, it's a 3 by 3, type in all my elements. 0, 2, 1, 3, -1, 2, 4, 0, 1. All right, once you have it typed in, you're going to go to matrix, and then you're going to go to the math column. We haven't used this one before, but the first operation that it'll do for you is to find the determinant. So I just hit enter. It'll say determinant of what? I need to put matrix A into here. So if I hit second matrix and I hit enter right here. It'll copy matrix A into here, hit enter, determinant is 14. Yay? All right. Okay, and really, again, you kind of have to do this for any 4x4, because let me walk you through, like I said, what a 4x4 looks like. So to do a 4x4, all right, I would pick any row or column to use. So I pick this one. I need to find this one's cofactor. To find this one's cofactor, I take the determinant of the matrix created by eliminating its row and column. But that's a 3x3. So to find this one's cofactor, I need to find the determinant of this. Well, how do I find the determinant of that? I pick any row, right? And then I need to find this one's cofactor. Well, how do I do that? I eliminate it, and I do this. And then I find this one's cofactor. Then I find this one's cofactor. And then I multiply them by the sign change and all that, and this, add it all together, and that's giving me one cofactor. So I have done 3 determinants to get 1. I then need to repeat that for number 2, and then I need to repeat that for number 3, and then I need to repeat that for number 4. So in order to get the cofactors for this one, in practice, you end up having to do 12 determinants. If this was a 5x5, you'd have to do 60 determinants. If it was a 6x6, you'd have to do 360. So you work for NASA, they go, here's a 6x6 determinant I need by lunch. Right? There you go. Oh my gosh. Imagine also like the chances you mess up one sign change and that whole 60 lines of determinants. So really, you don't have to do it once, you have to do it twice, at least, right? Just to make sure you got it correct. Because if you send them the wrong sign change, that could have disastrous effects when it's actually plugged in, which has happened. Like there's been satellites that were supposed to be sent to orbit Mars, but in one line of calculations, the person doing it forgot to change from feet to centimeters or something for a sign change to match everyone else's work. So when it was plugged in, they ended up missing Mars by like 1,000 miles. And that satellite just went careening off into space. That happened. That's for reals. So just be glad you got this small device that you can get for free on Android right now on your phone to do all that work for you. All right, try this one by hand, and then you can double check it with your calculator. As a reminder, you can use any row or column to do this. And there is an easy column to use. But again, if you end up just doing it with the first row, it's not really that much work. The 0 will help you out later in the problem then. I'll give you 3 minutes. All right. What do you think is the easiest row or column to use? The far right one. This is probably the easiest one to use. Again, you don't have to use it, but I just think it'll be the easiest. So that I'm going to really, because this 0, 1 won't matter, right? I just need to find the -2 and the 1. So if I find the -2, eliminate this here. I'm going to do the determinant of 3, 5, -1, 4, which is 12 plus 5, right? Because it'd be minus -5. So that's 17. Again, the middle one won't matter because whatever the answer to 3 times 4 minus -1 times 4 is going to be multiplied by 0. Oh, sign change. Top right number is positive, so I'd multiply this by +1, so it'd say 17. Okay, now this one, 1, eliminate this. 3, 4, 3, 5. So that's 15 minus 12, so that's 3. Sign in the bottom is also positive, so I'd multiply that by +1, stays 3. And so then my answer is going to be -2 times 17 plus 3 times 1, -34 plus 3 is -31. Yay? Yay. All right. You got a homework due Wednesday. I think it's between 5 to 10 problems. You can use a calculator to help you find and check your determinants for all of them. If it is bigger than a 3 by 3, you should just use the calculator. I think it even says that in the instructions. Okay. All right, how do we feel about determinants, okay? And on Wednesday, I'm going to show you how to use them. And then you'll be like, oh my gosh. Or why we found them, what they're used for. And they're like, this is so much easier than solving a system of 3 equations with 3 variables by hand. You can do it with determinants in a quarter of the time. And as a reminder, I'm still taking chapter 3 work and test. So if you need extensions on any of that, let me know. Or if you want to retake anything too. Have a good day, everybody. See you Wednesday.